Hi, I'm Brent, a senior solution engineer for GitHub. For many years, I've had the pleasure of watching how GitHub has changed and grown, and how we've grown to address the problems that we face, and ultimately how we've overcome them. And more importantly, how we continue to evaluate how we can do better for everyone using GitHub. And at first, in case GitHub is new to you, GitHub is more than just open source. It's where the entire planet goes for software development. Whether it's internal software collaboration or within their community inside the company, or through the largest open source community in the world. So lots of people use GitHub, and we often get asked how GitHub builds software. And I think this comes from an interest of people wanting to work like us in such a scale. And we've historically talked a lot about how we work. And there's also just general curiosity. I personally love talking about this because I also get to figure out a little bit how we work, and it's just such a pleasure also to be a fan of GitHub and the company itself. And though GitHub has changed a lot since I've first given this talk, as well as it'll probably change by the time I end this talk, because we're always iterating, we've always focused around these 4 pieces. So let's approach these one at a time. First up, common philosophy. So these core philosophies and ideas are part of what we call the Zen of GitHub. And this can also be queried for the more developer-focused of you through using the command line like you see here on the right side of the screen, or just by opening a web browser and going to api.github.com/octocat. These guiding principles are something that I don't even think everyone may realize anymore within the company. Not every developer might realize these, but they've sewn themselves into the way we develop software. Keeping things fast, for instance, like under 700 milliseconds. Being able to speak like a human, very important in today's world where we're often not meeting face-to-face. But I think one of these in here, the non-blocking is better than blocking, is a great point to bring up about our next topic, asynchronous communication. So this is an old, outdated screenshot, but I think one that's important to think about going forward. So this is from January 10th, 2017. So you can see there at the top, we had around 588 developers spread across the world, different time zones. And then 2018-ish, we had a lot of growth. And as we grew, how did we maintain asynchronous communication? There's tools like Teams and Slack and other chat services that have been around forever. But what about maintaining asynchronous communication for software development? Now, this largely focuses, that asynchronous communication for us largely focuses around a topic called GitHub Flow. You may have heard of Git Flow if you're used to developing software within the Git ecosystem. GitHub Flow is a slight iteration, a simplification on top of that. And this is the way that we work. We do this for documentation as well as software development for all of the features you see on GitHub Enterprise Cloud, GitHub.com, and GitHub Enterprise Server. And just like with any other Git project, we will create a feature branch, add some commits onto that, and ultimately, we open this into a pull request. Now, this pull request is kind of the focal point of everything that goes on in GitHub. It's where we're going to be reviewing and discussing the code, but it's also where a lot of the integrations are going to come into play. You're going to have code review. You're going to have your code coverage test being shown there through different systems, and you're going to have automated tooling also being brought in to evaluate maybe some of the things that are being said. Now, once this pull request is created, we have a conversation about it. We review the code, we approve it as needed. But it's important to note here, like that Zen of GitHub I was talking about here. You see one user, Alberto, thanking Thomas for his review, right? Speak like a human. It's very, very, very important aspect into, I think, proper software development, proper DevOps mentality. You really can't have DevOps without collaboration. And if you aren't feeling welcome and included in a lot of work, you're not going to really have that good seamless friction between teams. And I think If someone's going out of the way to review your work here, speak like a human, thank them for their time. Now, like mentioned on the last slide, part of the discussion review step is for these third-party tools to help with approval. And we automate as much as we can. So you can see in this picture our automated test suite, which runs on servers every time code is pushed into our code base. These test suites include unit tests, functional integration test, and there has to be a passing CI build before changes are deployed out to GitHub.com. This gives developers the confidence and ensures code meets the quality standards that they set. You can see here in this picture, there's a few of these things marked as required status checks, meaning they have to have that green check mark. They have to pass before they go on to the next step. Different teams set up these different requirements as needed. Now, at GitHub, this is always the contentious point here. We deploy code from a pull request branch, and we only merge it into that main branch once it's been confirmed in production. The latest main branch is always merged into the feature branch, meaning we have that kind of reverse merge, if you're familiar with the term. So it's our stable release branch, that main branch, and everything on main is considered production-ready code. So if a branch deploy ships bad code by containing a bug or performance regression, it's rolled back by deploying the latest main to production. So I ship my feature branch. Oh, actually, this is going to be bad for our users. Okay, we'll just redeploy main on top of it. Now, at GitHub, we will not ship code unless it's been reviewed and it's not passing the required build steps. We don't force those deployments. That's a bad user experience. That's bad for our end users. So when this deployment happens, and I'll discuss this further in the presentation as well, it happens using our deployments API. And because it does that, we have that historical record in the pull request itself that the code the code that went out there into the deployment, in this case, maybe multiple deployments, seeing a production canary deployment and then that production deployment happening. And it's important that it lives in that pull request because that's our record of information. That's our historical context to allow more people to know how this work was done, how this feature was developed, and ultimately how it got into and in front of users. So how do we even do that deployment? And I said we use the deployment API to fill into that pull request. And how does this deployment aspect build on the previous two steps of asynchronous communication and that shared common philosophy that we have within the company? This all happens around a topic and a term called Chat Ops, but it also happens with the help of Hubot. You might be asking yourself, what is a Hubot? It looks like this little floaty robot. Hubot was once called the hardest working GitHubber by Wired Magazine. I think though that this screenshot is from this article is a little old. I think this is still very true. I think though collectively the entire company and all of our developers versus Hubot, I think we give Hubot a run for its money. Now, Hubot does many things like deployment tracking, seeing how many times we might have deployed within a given week, checking our load balancer graphs to check performance, knowing who owns what service, and what are the escalation paths when something goes wrong. Just thinking about that from a DevOps mentality. If you own the code and you need to know someone else's service is breaking your deployment, knowing how to contact them and sharing that responsibility to just fix the end result is very good. Hubot is also going to do things like have our instance and maintenance commands that we can see, setting up new servers, knowing when to tear them down, different things like that. And this is, of course, just 4 examples of what I can bring into one slide at a time. But in short, Hubot allows us to have that single point of traceability. It's auditable, and though you may not realize it yet, it allows us to have that ease of learning by having everyone do the work through Hubot. Previously you would watch people type these commands maybe at the computer. Even before 2020, this is the way that people would work, and you'd kind of pair program and see what people are doing. But if you can type these in a chat service, what you're doing is you're helping the inclusivity and learning across the entire company and across the entire globe. These commands allow you to essentially treat chat as your shared collective terminal so that people can help you if you're typing and learn from you if they don't know and understand what you're typing. So it's kind of two ends of that spectrum. I could probably do an entire conference presentation just on Hubot. You should find out more and get creative on your own as well. Check out hubot.github.com for more. And hopefully this inspires you a little bit to think about how to start automating and sharing that responsibility and ultimately having a little bit more of an inclusive culture through chat ops. So up to this point, you've gotten a taste of our workflows with pull request, some of the ways we review. You know that Hubot is this kind of magical robot that we've very much hardwired into the way we do some commands in chat, but how does this all come together for the continuous delivery aspect? But I think maybe more importantly, how did we get from where we are 6 years ago, maybe 8 years ago even, today, and what were the lessons we learned along the way? I think it's worth mentioning that GitHub itself, the product, is a monolith. So if you're thinking about microservices and quick deployments and things like that, GitHub is a monolith. So that in itself has its own challenges. So this is a screenshot of a very early GitHub, a deploy graph from a blog that we have in around 2015. And at early GitHub, we didn't really have deployment queues. We didn't have batch deploys. We didn't have as good of monitoring of the deployments like we did now. Hubot used to tell us to keep an eye on Twitter if we had a deployment, because enough people would complain about it through Twitter and we could easily see that. You know, but even still, back then in the past, you would deploy through chat, but you couldn't really queue yourself. All you could do is try to deploy. Because luckily, when we were deploying those feature branches, if we were going to handle the deployment in chat, we had to control not overriding each other's work. Right? Imagine if I was building some feature and functionality, moving a sidebar from the left side of the screen to the right side, and someone else wanted to move something completely elsewhere on the page, right? Or just even with visual exposure. Overriding each other's work by deploying over top of someone, that would be bad for the users. So we had to implement something like locking. So we were deploying through chat, but as we were trying to do it, we had this locking mechanism, because if someone had just deployed their branch, they're probably not done with it yet. And maybe a deployment is also just currently going out. And to do this many deployments, you need to make sure someone can't override you and by having that production lock. Now, one thing I want to make sure I call back to here is I said earlier that when we deploy these branches, the branch gets updated if it's behind. That's kind of one tiny little thing that we don't want a developer to have to worry about. So if you are deploying some feature branch out to whatever product, whatever application we're working on, and once that's done, you merge it into main, and then I want to deploy my branch, but now main has things that I don't have. So Hubot notices this and will update my branch with what you've just merged in. So that way we are always constantly moving forward with that. So it's just one little thing that a developer doesn't have to worry about. So locking deploys worked for a little while. Maybe this is where you're at with your journey today, right? Just implement some locking, some automation to keep your branches up to date so you can deploy those feature branches. But for us, we grew and we grew a little bit beyond this, and we had to change the way we dealt with what we were working on. And we had some rules in place for the then previously called master branch, now main. And they're too long to mention here, but things we had like rules that said, main is always stable. Nothing should be merged before being deployed. If it contains bad code, fix it by deploying a branch that reverts the bad code. And a process in place for things like passing tests, coworkers to review, deploy front-end environment first. And then one of my more favorite ones here, stop and think. Because you have to think about if you're in a position to change production, how could it go wrong? Should something be put behind a feature flag first? And then, ultimately deploy to a subset of live users and then deploy to everyone. So in order to make these enhancements, we had to be able to deploy to more environments instead of just locking those deploys. These were semi-isolated environments that worked off production code. So being able to touch real data, but not necessarily affect real visual changes to people. We had a number of lab environments that were available for testing. They replicated various levels of the production stack to balance speed and thoroughness. Now, one little caveat here, these lab environments received no normal user traffic, but they did, as I mentioned, touch real production Git and real user data. So your branch, if you deployed out to it, would cause an issue if it created bad data, it queued a bad job with a changed interface or something else to a system not running your code that it didn't expect. So your branch must pass CI before even being deployed to a lab environment, which of course, you want to make sure you have those setups correct, those setups and those protections set up before you do these deployments. So, and that worked for a little while even, just having the lab environments before you deploy out to production. But there were so many people deploying that to production even that we had to set up a queue. Even if we set up the required lab environments, later production deployments would take a while as well. So through Chat Ops, just like everything we've set up to this point, you would tell Hubot to queue me for GitHub or queue me to deploy, QMTD. And Hubot responds to you and says, hey, I've queued this, your feature branch up for deployment. There's one person ahead of you. And, after that lab deployment, when you're finally up in the queue, it's time for you to deploy to production, but you would deploy first with a Canary deployment. And this is a mandatory step. We deploy to Canary environment first. This environment is a minimal set of machines that reflects the front end stack. So like one front end, one API machine, one file server pair, one worker of each type, and so forth. If someone's testing on production, when you're ready to deploy, you can be notified when it's your turn when you're in that queue. And then Hubot will say like, hey, you're available to jump into the queue. You're ready to go. Go ahead and type deploy GitHub/my-branch to production Canary. Now, a Canary deploy cannot be accessed or tested directly. That's kind of what the lab environment's for. Its purpose is for preventing bad code from reaching every user. So it can still go wrong, but it's only reaching a subset of users. Canary is there to catch the regressions that you didn't find in lab. So instead of verifying your change in Canary, you kind of verify site behavior. You bring up our exception monitoring tooling before you deploy out to everyone. And 5 minutes in a Canary deployment was long enough for us to assume that a production deployment would not be catastrophic. So if you feel your change is dangerous in Canary or that you're blind to potential issues, we would consider adding metrics to that feature to track that in some of our developer experience dashboards. And being able to watch those graphs in real time to see if there's any changes. And if the Canary hasn't surfaced any issues, then you deploy to production. Just as I mentioned, kind of a 5-minute Canary deploy to have enough users hitting us globally that we would get enough data from that, even with a subset of a Canary deployment. And deploying to production works a lot like deploying to Canary, except you can now verify your change. Verify and change your behavior one last time to ensure there were no differences between the lab and production. Verifying site behavior for 5 minutes is kind of good to go. And if at any parts of your deployment fail, including any of the services, you can find out who's on call by running a command in chat to say who's on call deploys, and it pings them to find out that process. Now, this, again, worked for quite a while. But ultimately, we started to get into some pain points. And people kept filing in that feedback about those pain points. And one of the big pain points here is that the queue times got really bad. Imagine waking up first thing in the morning, you check some of your emails, you check some of your GitHub notifications, you start doing some work, and then you're like, oh, okay, maybe I'm ready to deploy this. Let me jump into the queue. Depending on where you're at in the world, the queue can be a wildly different set of time to deploy here. As you can see here in this example, a coworker of mine saying queue for GitHub, QFG, and Hubot telling that user, the estimated time for them to be ready in the queue is 3 hours and 19 minutes. So this is bad. So this kind of brought us to an inflection point over the last couple of weeks. A large part of this has all just changed. We kind of just finished wrapping up a large initiative around changing our process, and there's a lot here to jump into. We're going to be releasing a series of blog posts that talk about a lot more of this in detail, so you can get kind of a sneak peek now. But as we scaled these teams internally, some of the processes started to break down. Team size introduced bottlenecks that slowed shipping velocity. External drivers for change pushed us to reevaluate what could be done, enhancing data protection, slow deployments and long queues, acquiring a large set of new engineers. Maybe you can relate to that if your company is going through acquisitions. We built major functionality in CI/CD through GitHub Actions. We started a new product or two or three, and we had some major debt that we had to trim down. And we did, we trim away that debt bit by bit over the years. But it's time that to really address some of those developer pains. We did that with the kind of deployment queues and fixing some of that. But ultimately, there was larger underlying issues that developers had trouble with, internal developers had trouble with, that we had to surface, we had to talk about it, and we had to write it down so that we could address it. So this screenshot's out of date, but I think what's interesting is that in September 17th, 2019, there was around 449 engineers, but as of mid-October, there are double the number of engineers. There's over 900 engineers, not in product, not CTO office, things like that. So of course the queue times got longer, right? We had to fix what we had to do. And one of the main things we wanted to do, to give you a quick sneak peek of it now, as mentioned, these will be kind of discussed more in a blog post in the future. We had to create a new solution. If it was bad before we had queues and automated batching of these queues through entrainments and things like that, it got worse with more developers. So there's a quote here that says, when queues backed up, developers were motivated to ship changes in larger, more riskier pull requests to keep the throughput high. And we saw that, right? Developers everywhere always try to do this. I think they're motivated to, okay, it's going to take me a long time to get my deployment out, so let me combine a lot of things in it. That's not what you want. With DevOps mentality, you want to deploy more often. So as an internal project, a team was tasked with investigating improvements to our queuing system. And while the previous system kept us moving, it had some foundational issues, like developers needing to manually transfer approval of pull requests to these trains in our queues that we had. Chat Ops itself was the only way to interact with those pull requests, which is not really great. Not really great for a lot of people. And code could be directly pushed into these entrainment pull requests that we had, these big fat deployments that started to go out, and different things along the way that would kind of continue to make things a little bit worse. And a lot of these issues stemmed from the fact that everything lived inside of our software internal system called Heaven. And so we thought, we took that look inside, we took that evaluation and said, what would it look like to move more of this tooling closer to the monolith, aka hacking it into the web interface? And with this change, as I mentioned, there's no longer any trains listed here. You can kind of see this queue that's going on. This merge queue is very different from a previous automated train system, right? You're not joining a specific train. We found them to be quite problematic because it's difficult to make them fluid, depending on the timing of when people join. Imagine, if CI has to run right when something merges in together, and if you're combining all these different features to go out in one big deployment, you need to re-wait for CI to run every time. So we put a maximum limit on these now in these merge groups. We put a maximum limit on these merge groups to prevent them from getting too large. Merge group at the head of the queue can be deployed at any time. And on top of having better merging and queuing, our canary deploys that were so successful for so long, it only targeted about 2% of traffic before rolling out to 100% of traffic, unless you used a feature flag. But feature flags can be problematic. It can be problematic as well, as they can last too long. Now, this can fail to catch a lot of bugs, and we wanted to increase the number of canary stages, right? We had a 2% canary deployment. What about a 10%, a 30%, et cetera, to better validate the rollout of changes. We didn't want to implement a lot of new canary stages to put unneeded strain and stress on developers. So we developed a way to automate this into that merge queue I just showed for monitoring these deployments. Now, on top of this, we also wanted to have higher confidence into what we were deploying and less flaky tests. So we previously had a deployments dashboard that was kind of successful, but it was not really showing us all the things we wanted, and building those was cumbersome. So, we built this new dashboard from this initiative using Datadog, and we've used Datadog for a while, and it's very, very good. But now we're able to think about all these other systems and all these other initiatives that we have, and how can we put a lot of the developer confidence information into this dashboard, so as someone who's going through a deployment can monitor what's going on. So the background here is that we have all these new processes and tools around deployments, and we've always wanted developers to just feel more confident about it, and that's what our developers said internally as well. So we've built more of these. This is a kind of summarized deployment dashboard, and there's a lot of different drill-in dashboards into this as well. And this is, of course, just a small snapshot of that. So, below even this section on the screen of the canary deployments is, response times. Canaries are important because of that change to progressive rollouts that I just mentioned previously, on top of those merge deploys. But having this information front and center for the developer is very important for them to just feel safe and secure about what they're doing. Nobody needs extra stress in what they're doing today, at least not when doing deployments. So you have to present that information back to the developer so you can measure what you're doing. And yes, flaky test. If you're unfamiliar, a flaky test is a test that fails on your branch, but maybe passes in 10 others. No real reason. Bad infrastructure cleanup, goblins in the server, weird network lag, nobody knows, right? It just fails for one reason or another. And this is just a small snapshot of the interface. So when you find that flaky test, you need to know how to rerun the test to see it pass, where it's at, and what issues have been opened related to that flaky test. So as mentioned, flaky test, progressive deployments, and our work on the merge queue are just a sneak peek for you today. Showing these is just a sneak peek today. And in those upcoming blog posts, we'll be jumping into more of the details that make our internal tooling better to reduce developer friction and increase developer productivity at GitHub. Now, GitHub Actions is the latest, greatest way to use CI, but how much of it is used at GitHub and what for? Now, of course, at GitHub, we use GitHub Actions for running CI, for running builds, and things like that. But I think what's more interesting to think about with Actions is to have some workflow automation. So on the left-hand side here, we have a table, a markdown table, automatically generated using the small script that can almost reasonably fit on one screen on the right-hand side. And it's a bit hard to read, but what this does is this server will check out the code in the repository. You go to another repository to get a script, run some kind of script to create a generator. It creates this table and then commits it into a file somewhere. Now, this kind of automation is so interesting to me because, it's, like I said, it's not just continuous integration, it's workflow, how a team is tracking their efforts, and thinking about the art of possible here. What kind of advantages can you have with this? What if your team is using different types of project tracking mechanisms? If you're across different project boards or things like that, could you automate something to collect all this information together and present it in one screen? Could you run a GitHub action to look across multiple repositories to see what kind of security vulnerabilities are open there and create a PDF to present it to someone in a report? It's kind of where some interesting GitHub actions are to me. Now, Moda is another good tool that we have internally for how we develop today. Moda is GitHub's internal runtime platform, and it's a pleasure to use, very easy to quickly get started with. It's so fun for our developers that we've even built memes around this as well, right? Because developers, have been standing on the toes, facing ever longer deployments and difficulty with dependency management. So we wanted to build a set of norms, tools, and documentation and Kubernetes-based infrastructure to running services at GitHub. So we documented this. We kind of allowed our infrastructure team to have more of a product for everyone to consume. So this is a good question. How will we deploy tomorrow? How will we work? And I think this is largely left to imagination. We need to keep listening to our developers internally and to hear pains they're dealing with, to listen externally to find out what isn't going well for existing functionality, perhaps around reliability. And how can we make our users happier? We need to continue to think about the ways that deployments can go out more securely and more often. So some large takeaways here. We embodied our values, we empowered the developers, and we reduced developer friction to create more velocity. This is a little bit of a stock image to put in here, but I think what's interesting around this is this thought of, with wisdom comes more interesting findings, right? In 3 years, I think this presentation will be completely different. But a few things stayed the same. We didn't throw everything overboard when we were experiencing our growing pains. We still had that remote first mentality. We still use chat ops. Collaboration, the collaboration nature of chat ops has kind of replaced the casual conversations of a team setting. But what changed, it turns out a lot of the effort was spent in making builds and releases faster and more reliable. Deployments to production are inherently an experiment. Any change to software is an experiment, but the system is so huge, you think you know it, and every little change is basically a hypothesis. And you can say, I think I've accounted for all the edge cases, and I just tried to prove that with my test here. Both canary and locking deployments are ways to evaluate the result of those experiments. When a canary deploy happens, you're doing that same experiment, but that you do kind of when you're jumping into a pool, right? You kind of dip your toe in to make sure it doesn't completely freeze you. And you might have the question of, what's in it for me? You're working at a small company, not willing to invest that many resources. But I've seen places where even getting things like solid state drives for their CI systems is already a big enough deal to help the developers and save even a week's worth of time through just faster CI. Because ultimately, either your company changes or you will. And it's not your fault if things are the way they are, but it will be if they stay that way. So in a quote here from one of our principal developers said, at a certain point, we decided it was worthwhile to dedicate engineering resources to increase the velocity of our engineers. Somewhere along this timeline, we said, wow, we're going to staff this team with 12 people just to help us ship our own software, to build queuing systems and flaky test detections and things like that. Because people with high standards have high standards for the tools, and otherwise they'd leave the company. Engineers are expensive and fickle, and you pay these people who are expensive and fickle to generate business value. And if you want them to do that successfully, you increase their velocity to get feedback on that experience. So developer experience is so important for us at GitHub. One big takeaway from all of this is how much our developer experience has changed. We care about engineering productivity and happiness. It's the number one thing that GitHubbers asked for, a faster software development cycle. Easier would help too. Being able to make changes, get them in the hands of our users is good for business, and it's good for us. It helps reliability too, which helps our brand. Thank you.